Hi, my name is Caroline Bauman. I'm an undergraduate student at California State University Northridge studying geography and deaf studies. This is my senior capstone project titled Quantifying Potential Spatial Accessibility to Adult ASL Classes in LA County. Imagine this scenario. Hearing parents with no knowledge of deaf culture have a deaf child. They decide they want to learn ASL to support their child. Will there be ASL classes near them? Over 90% of all deaf children are born to hearing parents who typically do not know ASL or deaf culture. But learning language is a time-sensitive issue. There's a concept called the critical period of language development, which means that in the first 5 years of a child's life, they must access language. If not, they will experience language deprivation. For deaf children, this must be assigned language, and the easiest way for children to access language is through their parents. Language deprivation has a host of negative problems that can be listed here. Language deprivation is permanent and cannot be solved even with linguistic therapy or decades of language use. Furthermore, people that suggest cochlear implants need to understand that they do have associated risks. They do not guarantee success in producing auditory stimulation or adequate language development. A lot of research has also shown that the level of signing support available to families heavily depends on where they live. Now, if parents can't access ASL classes near them, they can learn ASL online. However, it's important to note that parents overwhelmingly rank formal ASL classes as the best way to learn ASL. There have been many methods to calculate spatial accessibility, including Euclidean or straight-line distance, network distances, models including travel time, traffic, and even gravity, and cumulative measurements, including physician to population ratios. However, all of these have limitations in the ways that they try to approximate human behavior. This brings us to the two-step floating catchment area method, which improves on previous spatial accessibility limitations by including a network, time, provider to population ratios, and even gravity. It has two steps: to calculate the provider to population ratios and aggregate them into a spatial accessibility index. It uses three types of data: population, providers, and a road network. And finally, it uses a user-defined catchment area based on distance or time. In each of the two steps, we'll apply a distance decay. Without a distance decay, we assume that the population is equally as likely to access a provider 5 minutes away as they are when 30 minutes away, which is not always true. One proposed solution is the enhanced two-step floating catchment area that uses a set of concentric rings with each a different weight. However, this still has similar limitations within each of the rings. Thus, we'll apply a distance decay function that gives a higher weight or importance to places closest to the population and gradually less of an importance as we go further out. The two-step floating catchment area method has been used to calculate spatial accessibility to healthcare locations, but not ASL classes. In fact, there's a lack of literature investigating spatial accessibility to ASL classes using any method. Thus, my question is, how does potential spatial accessibility to adult ASL classes vary within Los Angeles County? I chose LA County as my study site because it has a large population, a big deaf community, and notable schools that offer ASL classes. I used three types of data for this analysis: population points, road networks with their speed limits, and the locations of ASL classes as well as their capacities. I downloaded population from worldpop.org as a raster with a 100-meter resolution and converted it into points in ArcGIS Pro. For a road network, I used Esri's North American Road Dataset and made it into a transportation network using ArcGIS Pro's Network Analysis extension. For ASL learning locations, I downloaded a set of post-secondary educational facilities from 2019 through 2020. I then used the school websites to find out if ASL classes are offered, what the student-to-faculty ratio is, and what the different levels of ASL classes they offer. I also expanded the dataset by including deaf community organizations that offer ASL classes. Finally, I calculated the capacity for each of the locations by multiplying the number of classes offered by the student-to-faculty ratio. Here are the ASL learning locations in LA County, and here are the ones that are actually deaf community organizations represented by the stars. I use the two-step floating catchment area method in ArcGIS Pro to calculate spatial accessibility. The equations for the two steps can be seen here. First, I calculated the provider to population ratios, and then I aggregated them into a spatial accessibility index. For both of the steps, I used a 30-minute drive time catchment area. I also applied a Gaussian distance decay function, which you can see the equation for here. Here are the results of the analysis, with areas of high spatial accessibility in red and areas of low spatial accessibility in a lighter yellow color. There are 3 high spatial accessibility locations that I identified: the San Fernando Valley, Lancaster, Palmdale, and Long Beach. Here they are with schools overlaid, showing their given capacities. The San Fernando Valley has 3 schools that have good ASL capacities: College of the Canyons, California State University Northridge, and Pierce College. However, it's a little bit lower spatial accessibility because there's such a high population in this area. Lancaster Palmdale also has 2 schools with good ASL. This is Antelope Valley College and University of Antelope Valley. However, the population is much lower here, which is why the spatial accessibility is a lot higher. Long Beach doesn't necessarily have big ASL programs, but it has a lot of ASL programs scattered throughout, which makes the whole area have a decently high spatial accessibility. These are the low spatial accessibility locations: the Santa Monica Mountains and Central Los Angeles. These are them with the schools that do not offer ASL classes overlapped. Central Los Angeles has many schools that don't offer ASL classes, most notably University of Southern California. Also, there's a very high population in this area, which means a higher demand. The Santa Monica Mountains also has low spatial accessibility, partially due to Pepperdine University not offering ASL classes, but also due to the fact that roads here are often slow speed limits and very few due to the mountainous terrain. Finally, you can see the influence of freeways on the results as they expand the 30-minute drive time catchment areas. There are some limitations for this research. First, I only focus on spatial accessibility, not other forms of accessibility. Also, I use online data collection, so if places don't have a website, I may have missed them. Also, parents can learn ASL online, but it's important to remember that most parents overwhelmingly rank formal ASL classes as the best way to learn ASL. Finally, this project assumed parents have access to a car, which is not always true. Based on the results, I have some recommendations. Central Los Angeles and the Santa Monica Mountains areas would benefit from more ASL classes. Thus, deaf community organizations should focus their resources in these areas. Also, if high schools in these areas already offer ASL classes for students, maybe they can offer night classes for parents. Also, this research could be used to advocate for tuition discounts or cuts, free or affordable childcare, transportation aid, or even a modified or expedited application process for parents of deaf children. Based on the results, here are some schools that should offer ASL classes. Furthermore, if you want to, you can sign these petitions for USC and Pepperdine to start offering ASL classes at their schools. Some final remarks. It is unreasonable to expect parents to move just to learn a language. There needs to be good accessibility in all locations because we cannot accurately predict where deaf children will be born. The effects of language deprivation are not only extremely limiting and irreversible, but they can be avoided. Los Angeles County as a community has the potential to support parents in their upbringing of deaf children, yet it needs some more work. Deaf children deserve access to language, and they deserve the right to build that relationship with their parents. Understanding spatial accessibility to adult ASL classes is a crucial first step in tackling this problem. I would like to thank Jordan Ekman and Sohel Borashaki from California State University Northridge for being my advisors on this project. I would also like to thank the California Association of the Deaf for inspiring this project. Here are my references. And if you have any questions, you can contact me here. Thank you.